I could bring it up. So
Have you uploaded it?
I have a PDF of it,
Yeah.
so I could do it. Oh, look at that. Oh, look, I already scheduled it. That's funny. Okay, it looks like we're here. We're live. We're live. Once again, I'll let give it a second for people to pop in before I actually I should am I yeah, okay. I'm like, did I unmute myself? Step one in live streams. So I don't know. Let's see if anybody hops in. Or we could throw the let me see if I can throw the link somewhere too. Okay, we'll take care of it. Sweet. Okay. All right. Well, anyway, we're at Space Weather Week still. Oh yeah, so Janelle also wants to know when that massive coronal hole is supposed to come into view. So we'll have to bring that up, I guess. Bring up the SDO imagery.
Yeah, we'll take a look at it.
Yeah. So we will do that. Okay. Okay, sweet. All righty. Well, welcome in everybody. We were doing another stream from Space Weather Week workshop. I keep calling it Space Weather Week, but it's Space Weather Workshop. I think Space Weather Week is another thing. Um, so we wanted to discuss today a couple things. First is the ovation frustration, which is what we like to are referring to it as. That happened a couple days ago with this transient structure that came through and caused some aurora, but it was stuck in a convective pattern for a long time, and ovation wasn't reading right. But we'll get into that. I should say reading because it's a model, but anyway, that's neither here nor there. But we figure we can start with current conditions and for what's in the forecast and that fun stuff. And we'll get to the future. I say forecast, but we'll get to like the future forecast because there's already been some media hyping going on about the big coronal hole that is starting to rotate into view. And that will still be that'll be next week sometime when we see that. But it is a pretty decent looking coronal hole. So the biggest one of this year so far. So that holds some great potential, I think. So I will share my screen. Of course, it's on desktop, so let's go to the real-time solar wind. And as you can see from here, things have quieted down quite a bit. Basically kind of background level stuff. Was the solar wind speed is now back into the 300, upper 300 range. Density is down. BZ is just fluctuating really right around zero. So there's nothing really to be excited about here. For those that were hoping for maybe some aurora tonight, it's going to take us getting hit by something to push this. But there are some transient structures that Swipsy has talked about in conjunction with this coronal hole, the small one, not the big one, that is forecasted to show up tomorrow. I think it's Friday into Saturday. So we could see enhancement again, but it's right now a waiting game. And for those that have been watching EPAM, because we know the electron proton monitor on ACE, we wanted to address that because it's having issues. You probably notice big data gaps in it if you're looking at it. So it's not reliable at this point in time, unfortunately. So it's kind of just to wait and see if we see anything that in the solar wind. So that being said, you wanted me to drive the slideshow, right? So I will bring that up. We're gonna go into our ovation frustration and talk about this great thing. So let's see here. This, and I'm going to pass this over to Christian. He'll take this for the first part of it, and then Tanya will take the magnetosphere part of it because it was quite a bit of frustration. It got shared a bunch on the interwebs, and it didn't match what we were seeing. So therefore, I will hand it over and shut up. Well, hold on, I got to mute myself too. Okay, all right.
My mic doesn't come on until yours is off, so that's how we'll run this. Okay, yeah, ovation frustration, which I'm sure all of you have seen by now. And me and Mary Beth both made an individual post yesterday that kind of ran about it, which hopefully got some of the point across. But of course, it's always nice to reiterate something that is really frustrating. So to start off, this is the active satellite data that we have here. Let's see. I want to go over. So this is the actually before 19, 20, 100. Yeah, okay. The big one's just hidden in that little square. So this is when the satellite switched from ACE to Discover. At this time, ACE shut offline, or at least data was not being received, so we weren't actually sure which was which. But as of about 2000, I want to say UTCs, or around the time I saw it shut off. So if you go down in the real-time solar wind area to series, you can pick which spacecraft, or you can leave it as an active spacecraft for default, and it will auto fill in which one is doing which. But if you want to see them individually, you can pick one for ACE, one for Discover, and you can see the data differences during times like this. So at this time, ACE was not working at all. So we went to Discover. The main part I want to bring up, and again, it's a little bit hidden by the square, but the giant increase that looks like an impulse initially in data, and then it just horizontally goes over, and then it'll start zigzagging a little bit. But it's that's a pretty common sign of just an issue with data taking. That and the fact that well, actually, it looks like I'm assuming extrapolated. Oh, because then it went up to the 600 there. So that 600 bit is where it kind of started malfunctioning. It looks like it filled in the ACE part of this. So the Discover looked a little different. In fact, can I share my screen for just a second? I wanted to bring that up individually. So this is ACE on its own, and this is the general time period. It did receive some of the data after that time. Let's see. And it auto filled in for it as well, but it just stopped. There's a huge gap there. And then you go down to Discover, which at this time, solar wind speeds were 387-ish, not really above 400. We're going to Discover itself for that same time period. We see, holy crap, it's all the way up to 600. Well, Ovation model works specifically on the solar wind data that's coming in, the active solar wind data at that. And at that time, it was Discover. I will stop sharing if you want to go ahead and reshare those slides. Sorry, I know it was kind of sudden. So it basically Ovation took over and it used the faulty Discover data, which was the high solar wind speed, super high density, temperature, as if that were the actual data coming in, which then made the Ovation model explode basically instantaneously. When I say instantaneously, I mean the next frame. We even have kind of a GIF at some we can share. I think it's the next slide at some point, but where it just cycles through and you see it as a low end ovation and then boom, it's big. And then all of a sudden it drops back down after the Discover data is taken off because ACE recovers. So we had a lot of people share this. And ovation is normally something that people go to because it's easy, it makes sense, it's visual, it's supposed to show you the actual Aurora outline, whatever. You've heard our complaints about it. It's not something we prefer to use. So if you're going to use it, be sure to double check all of your verification. So in this one case with all these shares, and if you want to go to the next screen, that's fine. It's be perfect timing. Also, I'm still seeing it in a non-presenting mode. Oh, it got stuck. Oh, lovely. Okay, well, we'll get there eventually. But basically, we have like 5 or 6 different screenshots. They're not, I guess, terribly important to show. But the idea is they were shared everywhere and with a lot of people, and some even high-end people at this point that were sharing, and those got reshared everywhere as well. Normally not a bad thing, but in this case, this was telling people that there was major aurora about to take place, and there were none. And we went to ground mags for a while and a few different other sources and found that really nothing was consistent with the fact that the ovation was showing this high amount. And biggest red flag, honestly, if you ever see the ovation go from one value to the next value and it's super high, like I think it was 115 gigawatts was the most I ever saw on it, it's probably not real. Always, 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 always verify things first, especially models. If you have raw data, that's fine. Raw data is going to help more because then you can at least interpret it yourself or get somebody else to. but check your models before confirming. I think that might be everything while we wait for the slideshow to come back up, but if I missed anything, please let me know. As well as I think we have the actual video of it going from low to high to low.
Yeah, we do. I think I'm giving it to Tanya to share, because my laptop decided it didn't want to share things anymore.
Okay, fair enough.
So,
Well, in that case, I can show off the kernel hole.
Yeah.
sure. Yeah, go for it.
All right, well, got it up. This is as far as it goes. So this is 2300, which is a couple hours ago, but JHeliaViewer updates more slowly than the rest. I'm going to up the contrast dramatically. There we go, just so we can see it more. So this is the kernel hole it's talking about. There were two. It does look like they're starting to connect. That is a real possibility. We have this one here is the main one we're looking at forward to, which I say looking forward to. It's pretty small. It'll probably give us like a day's worth of high speed. Not expecting too terribly much, but let's see what kind of polarities we're looking at, because I don't think I've looked at that either. According to the PFF, red is positive, blue is negative. So it looks like a positive stream, which is not as good for spring. And then we still have the negative polarity over here. And if someone knows if those polarities are off, double check me, but I'm pretty sure red is positive, blue is negative in this case. Point is, though, it's a big kernel hole. So we could be seeing quite a bit from this, and assuming they're even connected, it could push things a bit further. I'm not going to make any forecasts or say what could happen. Let's wait until we see it at center disk and then decide from there. I'm ready to hand the screen off if everyone else is.
Sounds good. Are you ready?
Yeah.
Okay.
I'm gonna
Also,
share.
Janelle, yes, the raw data was bad. Discover data was bad, specifically for the solar wind data. Mag data is always fine, so don't worry too much about that. But the solar wind data for Discover was faulty at that time until ACE came back online, and ACE is currently correct.
I'm gonna share my screen and start the slideshow. At least try to start the slideshow if it works.
It works.
It works. Well, we're not quite there yet because now I have to do the slideshow. So let's see if that goes anywhere. So view, slideshow. And
The unplugged and unplugged.
yeah, we have Magnetosphere. So we had solar wind coming in. It was at the end of March 18th UTC going into early March 19th UTC. As you can see, it was a very, very gentle slide into steady magnetospheric convection because this just runs flat as it can get. And that's exactly what was going on with Aurora during that time. It was kind of boring. It had a few flare-ups, so people did report that a few rays were visible. But it definitely was not matching with what we were seeing in OVATION. OVATION had, I think, 117 gigawatts, and Aurora was showing up as this in both. It's a Gunflint Trail, so it's northern Minnesota, and you can count that as probably southern Canada. But it was going for several hours. So this is Michigan Isle Royale Skycam. It was going for a few hours while Discovery was feeding the data with very high solar wind speed and of course overblowing the OVATION. So 117 gigawatts didn't buy you much Aurora based on that data. I don't know, inflation. It happens. But later BZ actually switched back into something a lot stronger, and that was sufficient to feed the magnetotail and load it. And we did see some nice substorming later on, and it was visible in Skycams as well. And people did report Aurora during that time, including somewhere in Alaska, I believe, but it took some driving. So Vince Litvina actually reported Aurora from that time. So that's kind of a wrap on how things went that night. I'm going to stop sharing the screen. But did report Aurora during that time. Oh my goodness. Including some my apologies. I believe. Oh, yeah, malfunctioning buttons. Never fails. Oh, my sound is on again. So I'll stop sharing. We're having technical issues. So not only spacecrafts and models are having technical issues, we are having technical issues.
It's like being in the same place makes things worse.
Yeah, no, it is what it is. All right. So technical issue solved. Ovation model is a model. And with any type of model, you are what you eat. So what is being fed into the model will show up. So if the data is not matching, if you see that Ovation or any type of model data is not matching what you're seeing in Aurora and what you're seeing in Magnetosphere, it's always good to verify and go to the source and actually validate whether or not the model is getting the data that is consistent and matching the response or not matching the response you've seen. I think that's pretty much it.
Yeah, I think so too. We got what we need to cover, and the sun is like
Yeah, I know.
right in my face, but that's fine. Yeah, I think we just wanted to go over the ovation thing because that was a big it's one of those things. It's like so we have all these data products and we have all these things at our disposal, but we have to use them with caution and not like blindly follow them all the time, especially when they're model derived, even the real-time data too. So it's just, we use it with caution, especially if you see things are kind of amiss, like things just aren't quite lining up. As we like to say, the ground mags really tell the truth. So if you look at the ground magnetometers and they're not doing anything but these, these models are saying you're supposed to be seeing like overhead aurora, then yeah, it's a pretty good indicator that, something is off. So this was a great example to get to because it got shared around pretty widely because everybody's excited. They want to see Aurora. And I do realize that people in the mid latitudes have had a drought of this because of the cloud cover has been so bad. So everybody's hungry to see it. But yeah, patience, just be patient. It'll get better. If we have a couple coronal holes on deck that could give us something, even if the one is a positive polarity, but it's a big one. So we could possibly see something from it, even if it's short, not like super sustained or anything, but so we'll just keep an eye on it. I'm sure Space Weather Prediction Center will put out a forecast for that as in the upcoming days when it becomes more Earth facing and they can get an idea of what it looks like. So just be patient and I'll look to check to see if there's any more questions, but I think I got all of Janelle's concerns. She was the main one that was messaging me, so I wanted to make sure, I got at least those questions answered. But if you have any more in the chat, let me know. But I think that might be it.
Can we play now that we have the slideshow up, the ovation video?
Wait, what? I can't hear you.
Oh,
Probably. All right. I don't know what he said, but
check the chat.
I mean, I can hear you, but I think I have my laptop computer. Yes, it's down. So say it again. Say it again. One more time. Sorry.
Take a look at chat.
Yeah. Oh, chat. Chat. Okay, hold on. Oh, can we play the video for ovation? Okay, yes.
Yeah.
Yes.
Should.
Okay. Hold on. Let me see if it'll actually let me. I'll have to give it back to you to play because my screen's not sharing anything. So we'll play the video. Play the video. Hold the thought.
Get back going into
Okay.
echo.
Yeah. So because this video shows what the problem was with the satellite switch. So yeah. So hang tight. Here we go. Or not, or maybe.
Okay, possibly.
Can you just play it from that?
Hold on. I can do this. I can do this. I really can.
There we go. All right. So yeah, just watch this because you see it's like normal, and then it'll just like turn red. Right there. And then it goes back. So it's like snap on, or what is it? Clap on, clap off.
Clap on, clap off.
So that right there was the main problem for that. Janelle's like, aren't you literally the same place? Yes, we are. And it's causing more problems than what I'm used to because now you have to watch your volumes on the laptops and stuff. So we'll go back to our normal remote locations next week. And it'll be more put together.
Be more coordinated.
Yeah. So on that note, I will let you guys go for the evening. Thanks for joining. And if you know, like I'll do the whole YouTube pitch thing and, you know, make sure you like and subscribe to our little channel on the internet. Um, and then we'll come up with something to talk about next week. Maybe we'll have an event to talk about, maybe we won't. If not, you know, like usual, we'll go back to talking about something in research papers or, you know, something that's kind of interesting. So I will say bye-bye. You guys have a wonderful evening now. And like usual.